Dear students, how are you? I hope that you are all preparing well for your upcoming JEE mains examination. So, I am going to explain a few problems which are given in previous JEE mains examinations and the JEE examinations. So, what are the problems I am going to explain today? All were given in the previous competitive examinations. Okay. So, let us see the one by one. Okay. Coming to this first problem here, let f is a function from a to r defined by if x value is less than or equal to minus 1, the function is defined as k minus 2x. If x value is greater than minus 1, the function is defined as 2x plus 3. Okay now. So, if x is less than minus 1, the image is this. If x is greater than if x is greater than minus 1, the image is 2x plus 3. And one more thing he is giving that f has local minima at x is equal to minus 1, then possible values of k is. Whenever this local minima or local maxima is given, so immediately you should know the basic concepts. What is that basic concept means? This is local minima. It has x is equal to minus 1. X is equal to minus 1. Okay. Whenever it has local minima, if you draw a tangent here, it will to the left of minus 1, it will make obtuse angle. Okay now. If you draw a tangent to the right of this, it will make acute angle. That means as you are approaching from left hand side, the limiting value, that means the slope of this tangent is negative. As you are approaching from right hand side, the slope of the tangents will be positive. That means limit x tends to minus 1 minus, that means left hand side limit f of x is less than limit x tends to minus 1 plus f of x. So, this is a left hand side limit, that is a right hand side limit. Left hand side limit, right hand side limit. Okay. This is a less than, that is greater than. Why? Because it is an obtuse angle. So, the slope of the tangent will be negative. It is an acute angle, the slope of the tangent will be positive. Okay now, why? Because it will be in the first quadrant, it will be in the second quadrant, tan theta is negative. That means limit x tends to minus f of x is less than limit x tends to minus 1 f of x. Okay now, right. What is here? Limit x tends to minus f of x means k minus 2x is less than limit x tends to minus plus f of x means x greater than that side, that is 2x plus 3. Now, substitute here wherever x is there, substitute minus 1. So, this is equal to k plus 2 is less than or equal to, we can say sometimes equal to also. Why? Because at this stage both values will be equal. Okay. So, less than or equal to, so this is equal to minus 2 plus 3 1, k is less than or equal to minus 1, k plus 2 less than or equal to 1, therefore k is less than or equal to minus 1. So, your answer is A. Very easy concept. So, the first thing is whenever x is equal to minus 1, whatever may be that, if it has a local minima, that means negative to positive. So, left hand side negative will be negative slopes will be there, right hand side positive slopes will be there. Okay na? Right. I hope that you understand this solution. Let us go for next problem. Welcome to second problem. The real number k for which the equation 2x cube plus 3x plus k is equal to 0 has two distinct roots, real roots in 0, 1. So, we have to find out the value of k. We have to find out the value of k, so that two distinct real roots should lie in between 0 and 1. Okay, now actually it will have, since it is a cubic equation, it will have 3 roots. Okay now, but 2 roots should be distinct, 2 different roots should be in 0, 1. Then what is the value of k is asking. So the k value lies between 1 and 2 now, lies between 2 and 3 now, lies between -1 and 0 now, so it does not exist. Understand this? Let us see that. So before explaining this problem, so you should know one basic concept. The basic concept is, see here, y-axis, x-axis, any increasing function, whatever may be, so this is an increasing function, always increasing function. That means f dash of x is strictly greater than 0. Any increasing function have one and only one real root. Any increasing function will have one and only one real root. The same applies for any decreasing function also. If it is any decreasing function, it will have one and only one. That means it intersects the x-axis at and only one. Whatever may be that, either increasing function or decreasing function, it intersects the given, it intersects the x-axis at a one and only one point. Then only we call it as an increasing function. Okay, now, if you know that concept, the problem will be very, very easy. Let us see this function f of x is equal to 2x cube plus 3x plus k. Let us see, check whether this function is an increasing function or decreasing function. First, to find out f dash of x. So what is the f dash of x? This is a 6x square plus 3. Whatever may be the values x, 6x square plus 3 is greater than 0. 6x square plus 3 is greater than 0. So everybody knows. That means this is an increasing function. It is has increasing function. Therefore, it has one and only one real root. That is x is equal to 0. It has one and only one real root. The function will have one and only one root. It does not have two distinct real roots in 0, 1. If at all, if it is intersects between 0 and 1, it is intersects between 0 and 1, it will have one and only one real root. That we cannot say x is equal to 0, but it has one and only one real. Whatever may be the value of k. Okay, now, then since f dash of x is greater than 0 for all x belongs to real number. Therefore, then the real number k, actually it does not exist. It does not exist. It does not lie between 1 and 2, does not between 2 and 3, it does not lie between -1 and 2, 0. So actually it does not exist. K value does not. So whatever may be this k value, why? Because when you are taking the first derivative, it has become 0. So whatever may be that k value, the function is an increasing function, and in between 0 and 1, it intersects at 1 and only one point. Therefore, it has a one and only one root, real root. It cannot have two distinct real roots in 0, 1, right? So your answer is does not exist. So this problem was asked in 2013. Okay, so if you have this basic knowledge, that is, what is the basic knowledge? Every increasing function or every decreasing function intersects the x-axis at one and only once. It has only one real root, whatever may be that x, where it intersects, that is your real root. Okay, na? I hope that you understand this solution. Let us go for next problem. Welcome to next problem. Here the problem is, if x is equal to -1 and x is equal to 2 are extreme points of the function f of x is equal to alpha of log of mod x plus beta of x square plus x square, then what are the values of alpha and beta? Alpha and beta, so options are given. So the question was asked in 2014 JEE mains examination. So first try to understand the problem. So what the problem is, at x is equal to -1 and x is equal to 2, these two are the points of extrema. Points of extrema means what? Here x is equal to -1, x is equal to 2. This function is getting either maximum value or minimum value. That means there are two possibilities is there. So this is -1 and it is 2, and it is -1 at 2. So at -1 the function may be maximum, and at x is equal to 2 may be minimum. But here if at x is equal to the maximum, here minimum may be maximum. Otherwise, we can say that the function minus 1 and 2, here also maximum and here also maximum. Otherwise, minus 1 and 2, here also minimum and also here also minimum. So, it is a points of extrema. Extrema means at these points, the function may be maximum, minimum, minimum or maximum, both maximum or both minimum. Whatever may be that, whatever may be this. So, when he is saying that point of extrema, here f dash of x is equal to 0. Here also f dash of 2 is equal to 0. F dash of 1 is equal to 0. Understand this? So, f dash of minus 1 is equal to 0. F dash of 2 is equal to 0. F dash of minus 1 is equal to 0 and f dash of 2 is equal to 0. Understand? So, that is the basic idea that we should have wherever it is there. So, it is f dash of minus 1, here f dash of 2, they are equal to 0. Why? Because if you draw a tangent at those points, the tangent will be parallel to x-axis. Since the slope of x-axis is 0, therefore, f dash of x means slope of the tangent at the point x is equal to minus 1, its slope is also 0. Now, let us find out the first derivative. So, this is f dash of x is equal to alpha into log of x derivative 1 by x plus beta by. So, this is a 2x plus 1 is equal to 0. Understand this? So, if you take cross multiplication, so this is equal to 2 beta x square plus x plus alpha is equal to 0. Okay, now. So, this is the quadratic equation. Actually, f of minus 1, sorry, f dash of minus 1, f of dash 2 means it has two roots. What are they? Minus 1 and 2. This quadratic equation has two roots. What are they? Minus 1 and 2. Why? Because f dash of minus 1 and f dash of 2 is also equal to 0, no? That means this quadratic equation should satisfy minus 1 and 2. That means minus 1 and 2 are the roots of this quadratic equation. Okay. So, how to find out beta value, alpha value? So, very easy one. First to find out the sum of the roots. Sum of the roots means what? Minus b by a. Minus b by a, that is 2 beta. Minus 1 plus 2, 1. So, therefore, beta is equal to how much? Beta is equal to minus 1 by 2. Beta value we got. How to find out alpha value? Product of the roots. Product of the roots. That means c by a. Product of the roots means c by a. Alpha by 2 beta. Alpha by beta. What is the product of the roots? Minus 1 into 2, minus 2. So, already beta value is minus 1 by 2. That is 2 beta is equal to minus 1. Therefore, alpha is equal to minus 1, minus into minus plus alpha is equal to 2. So, therefore, alpha is equal to 2 and beta is equal to minus 1 by 2. C is your correct answer. Okay, right. So, here the first thing observe means what? X is equal to minus 1, x is equal to 2 means when there has a points of extrema means there you will get either maximum value or minimum value. At that point f dash of minus 1 is equal to 0, f dash of 2 is equal to 0. That means what? F dash of, for a equation f dash of x is equal to 0, minus 1 and 2 are the roots. What is this f dash of x? So, this is a quadratic equation. Okay, now therefore, it will have a two roots, minus 1 and 2, sum of the roots I got, and I wrote the product of the roots, I got alpha value. Okay. So, I hope that you understand this solution. So, let us move to next problem. Welcome to the next problem. So, it is a word problem. So, very easy problem this is. Okay. So, it is almost a basic level problem. If you know the formulas regarding sector, the problem will be very easy. So, let us see this problem. 20 meters of wire is available for fencing of a flower bed in the form of a circular sector. In the form of a circular sector. The maximum area of the flower bed is. On the whole, there is a 20 meters of wire. So, there is a meter, wire is length is there. Its length is 20 meters. There is a long wire is there. You have to fencing off, that means in the round you have to take flower bed in the form of a circular sector. In the form of a, this is a circular sector. That means these 20 meters of wire you have to put it in the round. Okay, now, right. Then what will be the maximum area of the flower bed? The maximum area of the flower bed. That means here the thing is, this is a variable things. The here length, this circular, there's a variable length, different shapes will be there. But this their circumference is complete. This circumference is 20 meters, but the area will be different. Area will be different. Now, how to find out the maximum area of that sector, circular sector? To know this problem, to complete this problem, you have to know two basic formulae. The first formula is, so let us take this is a theta, this is r, and this is r, this is L. L is the length of the arc. L is length of the arc. Okay, now. So the length of the arc is given by L is equal to r theta. The length of the arc, that means up to here. So this length of the arc is given by L is equal to r theta. Area of the sector A is equal to half r square theta. Those are the two formulas you should know. The first formula is the length of the arc is equal to L is equal to r theta. Second one is area of this complete sector. Area of this complete sector is equal to half r square theta. Now let us move the problem. Right. First of all, here area is equal to half into r square into theta. Here r is a variable, theta is also variable. Why? Because we will have a different shape. Of course, shape is that only, different sizes we will have. Here r is a variable, theta is a variable. This is our function, but we should write the function either in single variable, either r or theta. Understand? Either r or theta we have to write down. So for that we have one hint. What is that hint? Total circumference is equal to how much? 20 meters. What does total circumference means what? So this is the wire from here, r plus r theta plus r. That means r plus r theta is equal to how much? 20. This length is r. This length is r theta. This length is r. That is equal to 20 meters. So this is equal to 2r plus r theta is equal to 20. 2r plus r theta is equal to 20. So from this we can say, I can write it as a, in terms of, I will write it as a theta. This theta is equal to, how to write down? 20 minus 2r by r. Theta is equal to 20 minus 2r by r. Now, what is your area? So, area is equal to half r square theta. Theta means this, 20 minus 2r by r. So, see here, now total whole function I converted into r, single variable. That is our main motto, to convert. So, this is the function which we have to maximize. We have to maximize. Understand this? So, this is the function which we have to maximize. So, first let us simplify this. So, one r will be cancelled. Here one 2 is also will cancel. This is equal to 10 minus, here one r will be there outside, r into, here 10 minus 2 is also will go r. Understand this? Okay. So, once again telling a is equal to 1 r will be cancelled, r will be there. 20 minus 2r, 2 will take common outside, will cancel 10 minus r. So, this a is equal to 10r minus r square. So, this is your function, f of is equal to 10r minus r square. This function has to be maximized. So, for maxima or minima, what we have? F dash of x is equal to 0. That means f dash of r is equal to, that is 10 minus 2r is equal to 0. 10 minus, so 10 minus r, 10 minus 2r is equal to 0. So, this is equal to r is equal to 5. At r is equal to 5, the function will be either maximum or minimum, either maximum or minimum. For that, you have to find out f double dash of r. So, here what is a f double dash of r? That is equal to minus 2, which is always less than 0. Therefore, at r is equal to 5, the function f of r is maximum. I already explained why you have to take f double dash of r is less than 0. It is in my previous video, that's just 4 or 5 days back. Why f double dash of x is less than 0? Then the function will be maximum. And when f double dash of x is greater than 0, the function is minimum. I explained, just you go through that then. So at r is equal to 5, the function is maximum. So he is asking the maximum area. He is asking the maximum area. This a only you have to find out. So that is equal to a is equal to, that is a 10r minus r square. 10 into 5, 50. 50 minus 5 square, 25. 50 minus 25. So this is equal to 25. So therefore 25 square units will be your answer. So very, very easy problem. So generally circular sector means don't get confused. It is a sector only. Generally students will get confused about this word circular sector. Circular sector means sector only. So length of the arc, area of the length of the arc, area of the sector, r square into theta. I converted into single variable. Afterwards the problem will be regularly we can solve it. Okay na? So I hope that you understand this solution. Let us see one more problem which is also in this model. Okay. Welcome to this problem. So this is also very, very nice interesting problem. This is a wire of length 2 units is cut into 2 parts which are bent respectively to form a square of side x units and a circle of radius r units. If the sum of the areas of the square and the circle so formed is minimum, then see here, first of all there is a wire of length 2 units. So I am telling solution, there is a length of wire length 2 units, that is a AB, something one wire is there. It was cut into 2 parts. The one part is bent into in the form of a square of side x and another part is bent into in the form of a circle of radius r. Okay, so here he only is given the length of the side is x units and the radius of the circle is r. That means the perimeter of the square plus the circumference of the circle is equal to 2 units. What is the perimeter of the circle square? This is equal to 4x plus what is the circumference of the circle? That means this is a 2 pi r. This is equal to 2 is given. Right, we can cancel with 2. 2x plus pi r is equal to 1. Call it as equation number 1. Now here x and r both are variables. Why? Because we don't know where the wire is cut. That means somebody may cut here, somebody may cut here, somebody may cut here. They bent into a square and circle, but their shapes are okay, but their sizes will be different. Sizes will be different. Therefore, their areas are also will be different. Some of the areas are also will be different, surely. The only thing common is the sum of their perimeter and circumference is 2 units. That only correct. But the sum of the areas will be different. Why? Because we have different sizes. They are depending upon the where you cut the wire. Okay, right. So what is the area of this sum of these 2 areas? The area of the circle is square is x square. The area of the circle is pi r square. Right. So this is our function. Here x is also x is a variable. R is also a variable. But the function which is to be maximized or minimized should be in one single variable, either x or r. For in which we have to convert, let us convert this into, let us convert it into r. So a is equal to, what is our x? In place of x, I will write it as, otherwise you can convert into r. That means in place of x, I will write down 1 minus pi r by 2 whole square into pi r square. Understand this? So here from x I solved it. X is equal to 1 minus pi r, 2x no by 2. So now this is your function to be simplified. This is your function which is to be minimized. Okay. So completely it is in the variable, single variable, that is equal to r. So for maxima or minima, what we will do? F dash of x is equal to 0. So here also a dash, first derivative. So this is equal to 2 times 1 minus pi r by 2 into, that means this is a x square. X square derivative is 2x. Again minus pi r. Minus pi r means minus pi by 2 minus pi by 2 plus pi into r square derivative 2r, this is equal to 0. This is whole thing is x square derivative 2x, understand. Again minus pi r by 2, that is minus pi by 2 plus pi into 2r is equal to 0. What are the things that we can cancel? So here you can cancel 2 you can cancel, here pi also you can cancel. So let us cancel that. What happens here? This is 1 minus pi r, so minus is there, so you can write down this as a pi r minus 1 into pi by, here I am multiplying minus here, pi r minus 1 by 2 plus, of course I am cancelling pi, no, so pi cancel, here also pi cancel, plus 2r is equal to 0. Okay, now from this you can multiply with pi r minus 1 plus 4r is equal to 0. 4r is equal to 0. So from this what can you say? R value is equal to pi r plus 4r. So from this r is equal to 1 by pi plus 4. You call it as 1. R value is equal to how much? 1 by plus pi by pi plus 4. At r is equal to 1 by pi plus 4, the function will be either maxima or minima. Maxima or minima. To check for that, what you have to do? So you have to find out the second derivative of this function. But the thing is, generally these type of problems, even though if you find out the second derivative, that is f double dash of x, definitely it will be greater than 0 only. No need to check. But if you have time, you can check. That is, find out the second derivative. And substitute r value, that is 1 by pi plus 4, definitely you will get minimum means greater than or equal to 0, you will get. But no need to check. For this competitive examination, generally it will be there. Okay. If it is a descriptive examinations, you have to do and you have to show that. Okay. Now at r is equal to 1 by pi plus 4, this function will be, I am supposing that it will get minimum. Now you substitute here, you will get the answer. So from this what can 2x plus pi r is equal to 1, no? In place we have to get a relation, that is see the relation between x and r, we have to get a relation. Then how to get a relation? Very nice problem. So this is equal to, otherwise you take pi r value, take, why? Because here pi r is there, no? Pi r, take pi r value. So here pi r value is equal to how much? Pi r is equal to 1 minus 4r, you call it as second one, pi r. So substitute pi r value here, substitute, what happens? 2x plus pi r value is equal to how much? 1 minus 4r is equal to 1. Understand this? So from this I got pi r value. In the pi r you substitute 1 minus 4r. So any more cancellations? Yes. 1 cancel. 2x is equal to 4r, x is equal to, 2x is equal to 4r, x is equal to 2r. X is equal to 2r is your correct answer. Understand this? So very nice problem. This is a very easy problem. The only thing is, generally students they will got up to here. Afterwards they will struggle to get a relation between x and r. Okay. From this problem, one more thing what you have to learn is, generally no need of doing a double dash of x, f double dash of x, generally no need to do. Why? Because there is no option. Definitely here the options are also, see here, we got the answer. If it is any none or does not exist, that type of things are there, definitely we have to do double dash of x. But here it is already given that it is a minimum, and answers are also very clear. So there is no option such that none or does not exist, such options are not there. Surely you will get the answer. Okay, now I hope that you understand this solution. My dear students, I hope that you enjoyed today's class with some more problems and some more concepts. And tomorrow's class I will stand before you, and until then, all the best.